To draw a picture, whether you like to draw or not, it'll help you understand what's going on. You have a lighthouse, and in this lighthouse it is 130 feet tall. And there's a buoy out here, and you're at the top of the lighthouse. You look out at the horizon and you glance down to the buoy, and this is 6 degrees. Obviously I didn't make it to scale, that's okay. And I need to know how far the buoy is from the base. The base means the bottom of the lighthouse. And so I've got a triangle here. We're going to assume that the lighthouse is perpendicular to the base, or to the shoreline. So now I've got a right triangle, but I don't have any angles inside unless I go back to geometry and I remember if I have a parallel line cross and another parallel line, and I cross it with a transversal, these angles are equal. So here is my 6 degrees. Now I look at it, I've got an angle, I've got a side opposite, and I have a side adjacent. So I can remember through SOHCAHTOA that I'm going to look at the tangent of 6 degrees, and it equals 130 over x. You need to make sure when you put this into your calculator that you are in degree mode. So then I cross multiply, and then I solve for x. When I do that, I get an approximate answer of 1,237 feet. It ends up being 1236.9 something, but because we are looking at only 130 feet over here, we'll just approximate it to this answer. So now the next problem has to do with a tall building. From the top of a 100-foot tall Algent Hall, a man observes a car moving towards the building. If the angle of depression of the car changes from 22 to 46 degrees during that period of observation, how far does the car travel? So let's see, we've got a 100-foot tall building, and we're going to assume that the guy is laying down, he's looking out at the horizon, and he sees a car. My car is pathetic, but it'll do. And the car is moving towards the building. And as he looks down from the top of the building, he looks to the first time he sees the car, and this angle of depression is 22 degrees. Then the car is moved and he looks down again, and this angle is now 46 degrees. And the question is, how far did this car move from here to here? Now I don't know this distance either, so I'm going to call that D. And so now what we have here is we have a couple of right triangles. So before I forget, if this is 2 parallel lines cut by this transversal, if this is 22, then this would have to be 22 degrees. If this is 46 from here to here, this would have to be 46 degrees. Now based on that information, I now have right triangle, I have this right triangle here, and I have this right triangle here. And so now I have to write what I know about my trig functions. Okay? So if you think about it, I've got, let's look at the smaller triangle. I have a tangent of 46 degrees. It equals 100 feet over D. If I solve for D, I get 100 over tangent of 46 degrees. Now let's look at the bigger triangle. I have a tangent of 22 degrees, and it's 100 over x plus D. Well, I don't know D. Well, I really do. I have it up there. And so what we're going to do is we're going to cross multiply, and we're going to solve for x. Okay? So if I think about it, I have x plus d equals 100 over the tangent of 22 degrees. All right, so that means x equals 100 tangent of 22 degrees minus d. Well, what does d equal? Well, let's bring it up here. It's 100 over the tangent of 22 degrees minus 100 over the tangent of 46 degrees. Now you're going to put this in your calculator. Make sure you are in degree mode, and you're going to get x to be about 150.94 feet. And since we're not dealing with any kind of decimals here, we'll say x, the distance the car traveled, is approximately 151 feet. That's the distance the car traveled from the time the gentleman looked from here to here. All right, example 3 is talking about finding the height above ground. We have a large helium-filled penguin. It's moored at the beginning of a parade route awaiting the start of the parade. 2 cables are attached to the underside of the penguin, and it makes angles of 48 degrees and 40 degrees with the ground, and they are in the same plane as a perpendicular line from the penguin to the ground. If the cables are attached to the ground are 10 feet apart from each other, how high above the ground is the penguin? So what I'm going to do is I'm going to draw me a penguin, and he's got a couple feet, and they said it's from the underside. So we know that there's a height here, which is what we're looking for, and we know it says a cable is attached to the underside making angles. So we have a cable here and we have a cable here, and they're attached to the underside. And this one has a degree of 40, and this one has a degree of 48, and they tell you that these two spots are 10 feet, I think, across. And I have no idea what that distance is. Okay? So they're 10 feet apart from each other, and we want to know how high the penguin is above the ground. So we're looking for h. Now what we're going to do is we're going to actually take and write our tangents. And the reason we're picking tangent is it's opposite over adjacent. So I have x over h, and I'm going to solve for h, which is x times the tangent of 48 degrees. Okay. Doesn't help me too much because I now have 2 variables, and I need to find some other information. So let's look at the larger triangle. The tangent of 40 degrees is going to be h, but it's 10 plus x. So what I could do is I could solve for h, or I could put the fact that h equals x tangent of 48. So there's a couple things that we can do here. This is a lot more of an algebra kind of problem. You could plug in your angles, but then you have to worry about rounding errors. So what I'm going to do is I'm going to actually write the tangent of 40 degrees is going to be x times the tangent of 48 over 10 plus x. Now I'm going to cross multiply. X plus 10 tangent of 40 equals x tangent of 48. So I'm going to distribute that. I got x tangent of 40 plus 10 tangent of 40 equals x tangent of 48. Put the x's together. So how am I going to put the x's together? Well, I'm going to leave 10 tangent of 40 here, and I'm going to put x tan of 48 minus x tan of 40. And these are, of course, in degrees. I keep forgetting to put my degree symbol. And I need to actually factor. So I have 10 tangent of 40 is tangent of 48 minus tangent of 40. And that equals x. Once I have that number, I plug it into my calculator, I get 30.9045 and a whole bunch of other numbers. Well, let's Let's take it up to the top. Right here is what we're looking for. We're looking for the h. So I'm going to say x equals 30.9045 times the tangent of 48 degrees. So h equals roughly 34.32 feet, which we're going to round it to 34 feet. Now remember, we factored here, and then we divided to get x all by itself. Now you could have taken and put actual decimals here, and if you want to do it that way, you can. Just make sure you keep it about 4 decimal places. Example 4. A U.S. Coast Guard patrol leaves Port Cleveland and averages 35 knots. Now a knot is a nautical mile per hour. And he travels for 2 hours on a course of 53 degrees and then 3 hours on a course of 143 degrees. What is the boat's bearing and distance from Port Cleveland? Now remember, a course has to go clockwise from due north. So let's draw our picture. We actually have due north here, and it tells me that he went 53 degrees clockwise, and he traveled 35 nautical miles per hour. Well, before I draw that, that's 35 nautical miles per hour times 2 hours is 70 nautical miles. Okay? Let's know the distance. So let's go back to our picture. Over here, he went 70 nautical miles. Then he's here, and of course, from due north, he goes 143 degrees. And he travels another 3 hours. So I take, back over here, 35 nautical miles per hour times 3 hours gives me 105 nautical miles. So let's go back to where our Coast Guard is, and we have this one going 105 nautical miles. And they're saying, okay, we need to know this distance, and we need to know from north what's the bearing. All right, so now we have a couple issues here. We have 53 degrees. Well, parallel lines cut by this transversal. If this is 53, this has to be 53. Well, this is 143, and the whole thing is 180. Then 180 minus 143 gives me 37. So this is 37 degrees. Well, what's 53 plus 37? 90. So I have a right triangle here. That's great because later on we may not always have a right triangle. I need to find this hypotenuse. Well, good old Pythagorean comes into play. D squared is 70 squared plus 105 squared, and D is going to be the square root of this. And now D is 126.2 nautical miles. So that's one of my answers. Now I've got to look at how far I went. I need to find this angle here, because if I find that angle, I can add it to 53. Well, let's look at this. I've got an opposite and I have an adjacent side. So let's look at the inverse tangent, because that's the angle I'm looking for, of the opposite over the adjacent. And I put this in my calculator in degree mode, and I will get 56.3 degrees. So my bearing is going to be 56.3 degrees plus 53 degrees for 109.3 degrees. Because I said bearing, anybody who is trying to plot the course will know it's clockwise.